Today we are going to solve problem constrained subsequence sum, that is from leetcode. So you have been given an integer array nums. Okay, so if you feel like my speed is slow, then you can just increase speed using YouTube's inbuilt function. Okay, so let's start. So given an integer array nums and integer k, return the maximum sum of a non-empty subsequence of that array. Okay, such that every two consecutive integer in the subsequence nums I and nums j where I in condition is satisfied. So like if you have seen the problem maximum subarray sum, so in that we pick the maximum subarray that has the maximum. But in this case you have to pick element like if you pick 10, then another element you can pick either 2 or minus 10. So you have been given k edge 2. So this means the index can vary up to the k. So like if you pick 10, you can either pick 5, you can either pick 20. But let's say if you pick 10, then you can't pick 20. Okay, so let me paste this problem here, change the color, zoom little bit. Okay, so now let's see. Okay, so if you pick 10, let's see, if you pick 10, then either you can pick 2 or either you can pick minus 10. Okay, and if you pick 2, after that you can either pick 10, either you can pick 5, and the same with this one. If you pick 10, you can either pick 5, you either can pick 20, and you pick 5, either you can pick 20, and that is last element. So if you see this diagram, then you remember the question, that is maximum path sum in binary tree. Maximum path sum in binary tree. So where we try to find the maximum path, let's say this is the maximum path 10 to 5, this one, and here I think that would be 20. So let's say it is the maximum path and sum is 37. It might be possible that your single element is maximum. Yes, that is possible. It also possible that your path start from 2. That is also possible. Like if you start from 2, then 5, then 20, let's say like that. So in that case, maximum path sum subarray in binary tree, you can calculate the sum. So let's see the code. So the time complexity we will discuss later. So what you will do, every time you will try to reach the k index from the current index, and you pick the temporary. That would be like if I go here, so from bottom down it will return 20, and what it will do, it will say I have 20 in the my subtree. Now it will pick 20 plus 5, 25 from here, and 20 from here. Now you can see if I add minus 10 here, but which one, whether I should pick 25 or 20? Obviously I should pick 25 because that is maximum. So 25 will go up to the minus 10. Now it will become 15. Now let's say it is minus 30 and it is 25, then you can see it will become minus 5. But I would say our maximum would be in that case 25. So that is the maximum path sum in binary tree, and you can see this code. So we are returning the maximum of the subtree, and then we are checking with the maximum, that is current number, and then we are adding the temporary, which is this one, into the current array. After that we have defined one global variable that will check what is the maximum till now, and we will check the maximum here. But if we talk about the time complexity, in that case you can see that is order of n, and there are k iteration for each. So the time complexity is order of nk, and we are using memorization, so space complexity is order of n. But if I try to submit this problem, then it got TLE after 20 test cases. So we have to come up with a solution that is more efficient than order of n cross k. So either it can be n of k log n, either it can be order of n as well. I mean, whichever is possible, but it should be less than order of nk. So we have to think in other solution, like if I again paste here, we have to iterate, like if I am here, let's say if I'm here 20, then what I want is whatever the minimum till now here, either here or either here, what is the maximum. But if I want to know what is here, then I should know what is the maximum here or here, because k is 2. Then what can I do is, let's say I have one array, sum array, where I store the sum till I would say maximum sum till I. Then what I can do, if I want to pick I for I is equal to 2, then I can check sum 0 and sum 1, whichever is maximum. I can add the element nums I into maximum. So I will try to construct the array sum minus 10 and 5 and 20. So let's say initially sum would be 10. Now if I come to 2, then the sum should be 12, because you can see we have already 10 here. If I come to minus 10, then I can either pick 12, either can pick 10. Obviously I'll pick the maximum one, that is 12. 12 minus 2 minus 10, that would be 2. Now if I come to 5, then either I can pick this one, either I can pick this one. Again I will pick the maximum, that is 12, then that would be 17. Now come to 17, either I can pick this one, either I can pick this one. So I would say I will pick the maximum, then 17 plus 20, that is 37. Now again let's see one more solution, not solution, one more approach. Let's say minus 5 and 20. So now I try to construct the sum array. Initially that would be 10 minus 10, sorry, minus 2, and I will pick 10, that would be 8. For minus 10 I would pick obviously 10. So remember that we are picking from the sum, because that is the maximum till now. So I will pick 10, 10 minus 10, 0. For minus 5 I will pick 8, that would be 3, because 8 minus 5 is 3. And for 20 I will either pick 0, 3, I would pick 3, that would be 23. And remember k is 2 here. So you can see for k is equal to 2, we just see the previous k element maximum sum. So when I am talking about 20, does I care about 10 and minus 2? Obviously no, I don't care about these two. I just care the previous k element. So if you know, like, that become the sliding window problem. So where the window size would be k. And one more thing, all I care about the maximum. So let's say in window I have 2, 4, 8. So I always picking the maximum. So why I'm storing 2 and 4? I can get rid of 2 and 4. And after that, let's say in QE I have 4 and 6 and 2. So in that case, can I get rid of 4? Obviously, because I have maximum. Can I get rid of 6? Can I get rid of 2? Obviously not. Why? Because it might be possible when my window slides, the 6 can go. But in that case, the minimum, if I remove 2 as well, then my, one second, okay, one second, what happened? Okay, I need to reload it. Okay, so now if I remove 2, then you can see after removing 6 it will say there is no maximum, but I know that there is a maximum. So sliding, when this will slide, I will get rid of these 4 and these kind of things. So now if you see, this will be in a decreasing order always. So now come to the problem. Let's pick this one. I think we can pick this one and tweak some of the parameter. Okay, now initially we have this one. So I will create one Deque of size 2. Obviously I don't need to do. Initially it is 10, so I will insert, this is, remember this is a Deque. Initially I would say sum is 10. After that, when I come to minus 2, I know I have sum as 10, then I will insert 8 as well. When I come to 10, I would say I would insert 10 with 0. But once I do that, my window size increases, so I will get rid of 10. Now come to minus 5. Minus 5, I would pick maximum, that is 8, then it come 3. But when I'm inserting 3, I can get rid of 0. I don't need that, because in the greater element I already have the maximum. When I come to 20, I have to get rid of 8 as well, and then I insert 20. Sorry, 20, no, not 20, 23, because that is the maximum. Remember that 8 is removed, so that would be 23, and my final maximum sum would be 23. Now let's see the code. First of all, I have initialized Deque and initialized maximum sum, and the first element of sum as a num0, that is first element. After that, if Deque is empty, that is only for the first element, I will just add that element to the Deque. And if our first first element is out of the window, I will just get rid of it, I will remove it. And after that I will update my sum with whatever is first, because that would be the maximum for that particular window. And I will try to add num psi, and it might be possible your sum is negative or 0, then I will pick the element itself as well. After that I will update my maximum, because that is my variable, that is we store the maximum till now. After that I will maintain the decreasing q. So once I inserting some I will make sure the q is always in the decreasing order. So I will remove all the element that is less than that sum, and at the end I will add that sum into my q, and I will return the maximum. Let me submit the code. And to discuss the time complexity would be order of n, because we are iterating each element once. And space complexity would also be order of n, because we are using Deque, and as well as sum array, that is order of n, big O of n. And I think that's all. And yeah.